Okay, this is activity 2, rising water levels from lesson 7, representations of linear relationships. And there's a 7-minute video, roughly 7 minutes of video I'm going to show you in the beginning. And this is from using an online app that the authors provide. I'll provide the link to that app in the discussion below. So let's watch the video first, and then we'll come back and discuss what's going on in that video. So we need a different way to measure volume other than height, because in the first activity of those classes, the height was not proportional to the volume. And so what if that's not the case? And so they came up with this idea of measuring the volume based on the number of marbles added. And you guys know this, when you add ice cubes to a glass of water, the volume increases. And this is the same idea. You add marbles to a volume of water, the volume is going to increase. Now they used this cylinder. I wish they hadn't used this, because in this case the height is proportional to the volume. I wish they used a different shaped cylinder. And they also talk about level of water. And to me, level of water gives the idea of height. What's the level of that water? How high is that water level? And so I wish they had just taken out the word level and just put in the volume of the water. So they're going to begin with 60 milliliters. Now it says that you can change this level, and the lowest you can go is 40 milliliters. Then you can go every 10 milliliters, so 40, 50, 60, 70, 80, 90, and 100. So we're going to start at 60. So that's the starting point. That's the head start. And you guys know where that lands on the graph, because we talked about that. Where does the graph start? If it doesn't start at 0, 0, where is it going to start in this case? And then they're going to drop a marble into this cylinder and tell you what the volume of the water is. So drop one marble, and that volume goes to 3 milliliters. So how much did the volume increase? Well, you have to take away that initial 60 milliliters, and you can come up with the fact that that increase was 3 milliliters. Well, if you do that 3 times, so the second time goes to 66, third time goes to 69 milliliters. So what's the volume that was added based on the marbles? Take away the 60, 9 milliliters, and how many marbles did you add? 3 of them. So what's the increase based on each marble? So that's going to be 9 divided by 3. And then they ask you to go to 7 marbles. So let's go to 7. 5, 6, 7. And if each marble means an increase of what volume? Well, 3 milliliters for each marble. 3 times 7 is 21. And you remember you had that 60 milliliter head start. So 21 plus 60 is going to get you to 81 marbles. And then they ask for X number of marbles. So any number of marbles you add, what do you do with that number? Well, you're going to multiply that number. Let's say this number is X. You don't know that it's 9. You're going to take that number of marbles, multiply it by 3, but then you have to add the head start to it. So what are you going to do? You're going to add that 60 milliliters that you started with for the volume. And then they say, what happens if you fill up the container? How many marbles can you add to fill up the container? And this becomes an interesting question because it's not an equal number of marbles. So if you take away the 60 marbles, or I'm sorry, 60 milliliters, you're left with how many milliliters to fill up? Well, you're left with 40 milliliters. Well, 40 is not a multiple of 3. But what number is very close to 3? I'm sorry, what number is very close to, as I'm clicking these things, what number is very close to 40? That is a multiple of 3. Well, if I get to 12 marbles, that's 96, and take away the 60, I'm at 36 milliliters. 96 minus 60 is 36. Well, that's a multiple of 3. 3 times 12 is 36. Add 3 more milliliters to 36, you get to 39. And you can see that 3 divided by 3 is 1. 9 divided by 3 is 3. So 3 times 13 is going to get you to 99 milliliters. Why 99? Because it's 3 milliliters for each of the 13 marbles, plus you have to add that 60 milliliters that you started out with. Now this is an interesting question. It's going to flow over the top when I add this next marble. By what fraction of a marble would I have to add to get exactly 100 milliliters? If I could cut those marbles into pieces, what fraction would I add of a marble to get exactly 100 milliliters? So if I add this marble, it flows over by how much? It flows over by 2 milliliters. Well, what fraction is that of a marble that's flowing over? It's 2/3 of a marble. So 1/3 of a marble equals 1 milliliter. So if I could go back, I'd add 1/3 of a marble. That would get me to exactly 100 milliliters. And the other thing to notice before we move away from this, wherever I start, so now the starting point is 40, the slope of the line is still going to be the same. The amount of increase in volume for each marble is still going to be 3 milliliters. So I add 1 marble, this goes to 43. Add 2 marbles, this goes to 46. Add 3 marbles, this goes to 49. So I'd have to subtract that 40 milliliters from 49, gets me to 9 milliliters. Divide by 3, that tells me it's 3 milliliters for each marble. And what I want you to notice there is if we compare these two graphs, and I'm going to do that in a few minutes, they're going to have the same slope, so they will be parallel. But what's going to happen where they cross the y-axis or the vertical intercept? That's going to differ. In this case, it's going to be 40. And in the first case, it would be 60. But then you have parallel lines increasing at the same slope. They're just starting at a different point. So lots of stuff in this little activity. It's pretty interesting, actually. All right, so let's graph some of the information that we gathered from the video. So if you add 1 marble, what's the increase in the level of water, the volume of the water in the cylinder? Add 1 marble, it increases 3 milliliters. So the change in number of marbles is 1. The change in the volume is 3. You have to take that 63 and you have to subtract the 60. So you get an answer of 3 milliliters. Add 2 marbles, the change is 6 milliliters. So it's 3 milliliters for each marble. Add 3 marbles, the change is 9 milliliters. So it's 3 milliliters once again for each marble. Add 4 marbles, the change is 12 milliliters. 12 divided by 4 is 3. You draw a straight line, and notice that this line crosses the vertical axis, or intercepts the vertical axis, also called the y-intercept, at 60 milliliters, because this cylinder had 60 milliliters in it when we started. So now we're going to write an equation for this line using this slope triangle right here. So the change in the y value, it goes up with 1 marble, it goes up 3 milliliters to 63. So you have to take this y value and you have to subtract that 60 away from that. So this is y minus 60. So this is the left side of the equation where you have the y's and the x's. And what does that y minus 60 equal for this first marble? It equals 3. It went up 3 milliliters. The x, the change in x, because this is right against the y-axis, you don't have to subtract or add anything. It's just the value of x. So y minus 60 compared to x is equal to 1. X is equal to 1. So 3 divided by 1 is 3. So what that tells you is that this y minus 60, so the coordinate on this line at this point is y minus 60 is 3 times greater than this value for x. So y, so again, this point is equal to y equals 3 times whatever the value for x is, in this case it's 1, plus 60. So it's going to get you to a y value of 63. So if you subtracted the 60, and we did subtract that 60 in the beginning, it's right here, you have to add that 60 back to figure out what the y coordinate is, the number that is on the graph for the position of y, the y coordinate. So y is equal to 3x plus 60. You have to add that 60 back. So if we look at this in a table, add 0 marbles, you have a volume of 60 milliliters. So the change, if you add 1 marble, the change in x is 1 marble, that 1 marble that you add. What happens to the volume? The volume changes by 3 milliliters, or 3 units. Add 3 marbles, so the change is 3 marbles. What's the change in volume? The change in volume is 9 milliliters, so it's 69. How do you get that? 69 minus 60 leaves you with 9 milliliters. That's 3 milliliters per marble, so 9 divided by 3. Add 7 marbles, goes up to 81 milliliters, but what's the change? You have to take that 81 and subtract the 60. That leaves you with 21 milliliters, and that's because of a change in x of 7 marbles. So it's 7 marbles minus 0 equals 7. So how many milliliters per marble? 21 divided by 7 is 3. Now what happens if they give you the number of milliliters and say, how many marbles do you have to add to reach this 100 milliliters? Well, the first thing that you have to remember is you have to take away that 60 milliliters. And then you're left with working with the 40 milliliters. Now, if y is the number of marbles added times 3 is 3 milliliters for each marble. To go backwards, it's 40 milliliters, but you're going to divide by 3, or you're going to multiply by 1/3, which is the multiplicative inverse of 3. So to go backwards, I know the volume now. I have to figure out how many marbles that's equal to. So I have to divide that volume, 40 milliliters, by 3 milliliters for each marble. Every time I take out 3 milliliters, that's equal to a marble. Same as multiplying by 1/3. So notice that the operation is the same. 40 times 1/3 is the same as 40 divided by 3, and you get 13 1/3. Well, you cannot add 1/3 of a marble. So you have to add 1 more marble to get to 100 milliliters. So the cylinder is going to overflow by 2 milliliters. So the number of marbles you add to get to 100 is 14 marbles. Now the authors ask you to write the same equation, or write an equation using a different slope triangle. We use this slope triangle way down here first. So it's this slope triangle right here. So now we're going to use a different slope triangle, and we should, in the end, get the same equation. You have to get the same equation. So it's a nice way to check your algebra or check your math as you're going through to write that equation. So we're going to use this slope triangle right here. And so the change, if you add this many marbles, you have this change in the volume. So what are those two numbers? So the change, we're going to start at 69 milliliters. So we're going to go up to 69 milliliters, and we're going to add some marbles to get 81. So what's the change in the volume? Is this 81 minus this 69, which is the same as this 69 right here. So we're going to subtract that volume. We're going to end up with 12 milliliters. So there's a 12 milliliter change for adding how many marbles? Well, we started at 3 marbles and we ended at 7 marbles. So what was the change in the number of marbles we added? That is 7 minus 3 equals 4 marbles. So the y minus 69, so this is the change in the vertical direction. That y minus 69 equals 12 milliliters. And the change in the horizontal direction is x minus 3 equals 4 marbles. Well, 12 divided by 4 equals 3 milliliters per marble. Now what that tells you is that this this y minus 69, this amount here, is 3 times the number of marbles that are added. So this y minus 69 is 3 times, so you go from 4 marbles to 12 milliliters. That 12 is 3 times that 4. So this y minus 69 is 3 times this x minus 3. So that allows you to write this equation. Y minus 69 is equal to 3 times the change in the horizontal direction. So do a little bit more algebra. Y minus 69 equals 3 times x. If you have 3 x minus 3's, then you have 3 x's, and you have minus 3. You're subtracting 3 times. So that ends up being minus 9. Now, if we subtracted the 69 to get to this coordinate, and we want to know the number that you put in for that coordinate using the equation, you have to subtract the 69, y minus 69. That equals 3x minus 9. So now you have to add that 69 back. So you add the 69 back, but you have to take away the 9 at the same time. Add 69, subtract 9, that gives you the 60. So you're left with the equation y equals 3x minus 60. So 3 times the number of marbles added gives you the volume, but you have to subtract the 60 milliliters that you start with. That's going to tell you what the y value is. Oh, I made a mistake here. This is plus 60. I knew it didn't make sense. This is plus 60 right here, not minus 60. So y plus 69 minus 9 is going to be y equals 3x plus 60. All right, so let's write another equation. Hopefully I write it correctly this time, using a different slope triangle. So I'm going to use this slope triangle all the way out here, 102 milliliters. So we added, remember, if we added 14 marbles, we went over 100 milliliters by 2 milliliters. So what's the change in the volume? The change in the volume is 102 minus 60. So this 102 minus this 60 equals 42 milliliters. So it's y minus 60, and it's x equals 14. Remember, you don't have to move this at all or subtract anything because you're right against the y-axis. So x is equal to 14. So for 14 marbles, there's a change in volume of 42 milliliters. So the general term, using the x's and the y's for y minus 60 compared to x, that is a change of 42 divided by 14. So what's 42 divided by 14? That's equal to 3. So again, y minus 60 is 3 times the change in the horizontal direction, or 3 times the number of marbles. So y minus 60 is 3 times this x. Now you can write that. Y minus 60 is 3 times this x. Y minus 60 is 3 times that x. But if we subtracted that 60, so here I wrote it correctly, you have to add that 60 back. So y is equal to 3x plus 60, not minus 60, plus 60. So whatever you use, if you use this slope triangle, you use this slope triangle, or you use this slope triangle, you always get this same equation, y equals 3x plus 60, and sorry about that, this is supposed to be plus 60 right here. All right, so can you use this point right here, which is if you could add 13 1/3 marbles, you'd get a 100 milliliters. Can you use this point and this point down here, which is 0.60, to get this equation? How would you do that? Well, you subtract 100 minus 60, and you subtract 13 1/3 minus 0, and you're going to figure out the y and the x values. So you're going to use x and y and these values to figure out the slope, and see if you can come up with this same equation.